Arrhenius Equation. In our previous video, we already discussed about these 5 factors and its effect on the reaction rate. When particle size smaller, the reaction rate increase. When concentration, pressure and temperature increase, the reaction rate also increase. And when there is the presence of catalyst, the reaction rate also increase. Ini menunjukkan kelima-lima faktor ini memberi kesan terhadap kadar tindak balas. Tapi kalau kita tengok kesan 5 faktor tersebut terhadap rate constant iaitu K, kita dapati particle size, concentration dan juga pressure tidak memberi apa-apa kesan kepada nilai rate constant. That means kalau kita ubah size particle, kita ubah concentration, kita ubah pressure, nilai rate constant ni tetap maintain, tak berubah. Hanya 2 faktor saja yang boleh menyebabkan perubahan terhadap nilai rate constant K iaitu change in temperature dan juga presence of catalyst. To understand on how temperature and catalyst affect on rate constant, we will use Arrhenius Equation. This is Arrhenius Equation. K equal to A exponent negative EA over RT, where K is rate constant, A is collision frequency factor or Arrhenius constant, E is natural log exponent, EA is activation energy, R is universal gas constant with the value of 8.314 joule per mole per Kelvin, and T is absolute temperature in Kelvin. Now, let's discuss the relationship between temperature and rate constant K using Arrhenius equation. The first reaction is conducted at 20 degrees Celsius. The second reaction is conducted at 30 degrees Celsius. Perubahan suhu ni kita buat untuk melihat hubung kait antara suhu dan juga nilai rate constant K. Apabila temperature berubah daripada 20 degree Celsius kepada 30 degree Celsius, nilai constant A di sini tidak berlaku perubahan yang terlalu signifikan. So, untuk melihat perubahan rate constant apabila suhu berubah, kita akan tengok kepada value exponent negative EA over RT. When the temperature is lower, the value of exponent negative EA over RT is also lower. When the temperature is higher, the value of exponent negative EA over RT is also higher. Untuk lebih jelas kenapa lower dan higher, kita akan buat calculation. Let's assume a reaction with an activation energy of 50 kJ per mole. The first reaction is conducted at 20 degrees Celsius. So, kita substitute value activation energy dan juga temperature ke dalam formula exponent negative EA over RT. Nilai activation energy pastikan dikonvert kepada unit joule per mole dan nilai temperature dikonvert ke dalam unit Kelvin. So, the value will be 1.21 times 10 power of negative 9. The second reaction is conducted at 30 degrees Celsius. So, when we calculate the value of exponent negative EA over RT, it will be 2.38 times 10 power of negative 9. So, dekat sini kita boleh nampak dengan jelas apabila ada peningkatan suhu, value exponent negative EA over RT turut meningkat. For your information, the value of exponent negative EA over RT, it represents the fraction of molecules having kinetic energy equal or more than activation energy. So, kalau nilai eksponen negatif EA over RT ni rendah, maksudnya sikit sahaja molekul yang mempunyai cukup tenaga untuk membuat sesuatu reaction. Kalau value eksponen negatif EA over RT ni tinggi, maksudnya banyak molekul yang mempunyai cukup tenaga untuk membuat tindak balas tersebut. From Arrhenius equation, we can see that When the value of exponent negative EA over RT is lower, so the value of rate constant K is also lower. So we can conclude that the value of rate constant is lower when the temperature is lower. When the value of exponent negative EA over RT is higher, the value of rate constant K is also higher. So we can conclude that the rate constant value is higher when the temperature is higher. So the relationship between temperature and rate constant K can be explained like this. According to the Arrhenius equation, this one, rate constant K is directly proportional to temperature. When temperature increases, the term exponent negative EA over RT increases. Therefore, rate constant also increases. Next, we will discuss the relationship between activation energy and rate constant K using Arrhenius equation. The first reaction is conducted without catalyst. Let's say the value of activation energy is 50 kJ per mole. The second reaction is conducted with catalyst. Catalyst will reduce the value of activation energy. Let's say it reduced to 25 kJ per mole. Let's assume a reaction with temperature of 293 Kelvin. The first reaction is conducted without catalyst with activation energy 50 kJ per mole. So the value of exponent negative EA over RT is 1.21 times 10 power of negative 9. The second reaction is conducted with catalyst with the value of activation energy 25 kJ per mole. So the value of exponent negative EA over RT is 3.47 times 10 power of negative 5. So here we can see when the reaction is conducted without catalyst and the activation energy is higher, the value of exponent negative EA over RT is lower. When the reaction is conducted with catalyst and the activation energy is lower, the value of exponent negative EA over RT is higher. From Arrhenius equation, when value of exponent negative EA over RT is lower, so the value of rate constant K is also lower. So we can conclude that the value of rate constant is lower when the activation energy is higher. When the value of exponent negative EA over RT is higher, the value of K rate constant is also higher. So we can conclude that the value of rate constant is higher when the activation energy is lower. The explanation of relationship between activation energy and rate constant will be like this. According to the Arrhenius equation, this one, rate constant K is inversely proportional to activation energy. When activation energy decreases, the term exponent negative EA over RT increases. Therefore, rate constant increases. Thank you for watching.